In this lecture, we are going to see the polarization mode dispersion. It is one of the very important dispersion that cause degradation in the optical fiber communication. So PMD stands for polarization mode dispersion. It's a form of modal dispersion where it uses two different polarizations, namely horizontal polarization and vertical polarization of light in a waveguide. Ideally, it travel at the same speed. Travel at different speeds due to random imperfections and asymmetries that causes random spreading of optical pulses. But in the ideal case, both the polarization has to travel at the same speed, but they are traveling at different speed due to the imperfections present in the fiber and due to the asymmetries. What happens is it results in random speed and random spreading of the optical pulses. Instead of narrow pulse, we are getting the spreaded pulses. So we have to take more care to compensate this dispersion, otherwise it limits the bandwidth distance product. Hence it should be considered carefully. In ideal optical fiber, the core has a perfectly circular section. Here we have in the fundamental mode, LP01 is a fundamentally linearly polarized mode. Here we have two orthogonal polarizations, namely horizontal polarization and vertical polarization. The polarization is the resultant of what? The orientation of electric field resulting in polarization. Hence, the two will travel at the same speed. Actually, in ideal case, both are traveling at the same speed. The signal that is transmitted over the fiber is randomly polarized. That is random superposition of two polarization. Hence, it results in the degenerated modes will result in different speed. They will travel at different speed. Due to that, fiber birefringence occur. So polarization mode dispersion mainly caused due to fiber birefringence. How the fiber birefringence occur? It is due to the different polarization. They are not traveling at the same speed. They will resulting at different speeds due to the asymmetry and the non-linearities present in the fiber. So here in this diagram we can see in a single mode optical fiber, the optical signal is carried by the linearly polarized mode, that is LP. LP stands for linearly polarized mode. It is a fundamental mode, that is LP01. Here we have two polarization components that are orthogonal in nature. So in the diagram we can see there are two important modes, one is horizontal mode and the other one is vertical mode. So in the horizontal mode, it is along the x-axis having the refractive index Nx, and in vertical mode, it is along the y-axis having the refractive index Ny. So ideal case, Nx will be equal to Ny, but due to the non-symmetrical condition, both the refractive index will not be equal. So they will travel at different group velocities. Okay, in a real fiber, the two orthogonal polarization modes propagate at different group velocities, resulting in pulse broadening. Instead of narrow pulse, we are getting the spreaded pulses. This is called as polarization mode dispersion. And the group velocity is given by C by N. Similarly, we have two group velocity. Velocity due to y direction and velocity due to x direction. That is horizontal polarization, the other one is vertical polarization. So Vgy equal to C by Ngy, and similarly Vgx is equal to C by Ngx. The diagram we can refer, the initial case we have the pulse with very narrow, whereas at the output side, after traveling through some distance L kilometer, we can find the fiber output gets broadened, that is the pulse output get broadened, and there is a reduction in the amplitude also. That is del t time delayed version of the input pulse we can see. Here we can see pulse broadening due to orthogonal polarization modes. That is the time delay between the two polarization components. It is given by DGD, that is differential group delay. And the polarization varies along the fiber length. Polarization varies along the fiber length. With respect to length, the polarization tends to vary. Here, the fiber birefringence is the main cause of polarization mode dispersion. It is given as the difference between the two refractive indices, namely, it may be Ny minus Nx or Nx minus Ny. And here the fiber birefringence varies randomly because of thermal and mechanical stresses over the time. This diagram we can see the polarization mode dispersion. That is the fiber birefringence is varying randomly along the fiber with respect to distance. Here we can see at the initial state we can see see the here here we can see the initial polarization state. Then initial polarization state, the two that is x and y direction are given in this like this. So when it travels through the fiber, what will happen is initially the condition is like this. After some distance, the polarization states are changed. Okay, here it is changed, and after some distance also it is changed. So the beat length is defined in such a way that the initial polarization state, at what distance the initial polarization state is restored, is called as beat length. And we can see the input, and if you compare the input and output, there is much difference between input and output due to the different polarization resulting due to horizontal and vertical mode polarization. So what happens due to PMD is input narrow pulse gets broadened at the output, and the same is depicted here also. The input polarization state is denoted by V0, and after some distance it is given as V1, and after some distance there is a change in birefringence V2 and V3 likewise. So DGD refers to differential group delay. It is between VGX and VGY. Time delay between VGX and VGY. So we need to suppress the polarization mode dispersion. And here the polarization mode dispersion is mainly due to slight variation in the velocity of two modes, which results due to symmetric, non-symmetric conditions of the fiber. And hence we can define the delta polarization with respect to distance as L by VGX minus L by VGY. And we can find the RMS value of the differential group delay as delta polarization. RMS value of delta polarization is given by dPMD and into square root of L, where L denotes what? Length of the fiber. So we can denote the unit of PMD as picosecond per root kilometer. Hence L is given in square root. It can be given in square root kilometer. PS by square root kilometer. dPMD is a dispersion in the polarization mode dispersion. That's all about polarization mode dispersion.